Hello students, myself Savita. Today I am going to talk on types of organic reaction which is a part of BSc first semester chemistry syllabus under organic section. So before going to the organic reaction, let us have a recap about the chemical reaction, reactant, reagent and product. So, to know what is a chemical reaction, a chemical reaction is a process in which one or more react substances, which we call them to be as reactants, are converted to one or more different substances known as product with different physical and chemical property is defined as a chemical reaction. A chemical reaction, if it has to occur, a reagents is needed. So, a reagents are the compounds that are added to a system in order to cause a chemical reaction. Coming to the types of organic reaction, organic compounds undergo several different types of reaction based on the intermediate generated and the nature of the reactants. There are 6 types of organic reaction. In this video, we'll be learning the substitution, addition and elimination reaction. So, a substitution reaction is the one where there is a replacement of an atom with the other, and an addition reaction where there is an addition of an atom or a molecule resulting in the formation of product. And to the elimination reaction is the one where we are going to eliminate an atom and result in the production of an unsaturated. Coming in detail about the substitution reaction, a substitution reaction is a reaction when one group of atom or a single atom from a molecule is replaced by another atom or a group without any basic change in the remaining structure of the molecule is called as substitution reaction. The substitution reaction is a characteristic of a saturated molecule. The substitution reaction based on the type of reactive intermediates involved. We have 3 different types. An electrophilic substitution reaction when an electrophile has been involved, and nucleophilic substitution reaction and a free radical substitution reaction. Nitration of a benzene is an example for electrophilic substitution reaction, and hydrolysis of an alkyl halide is an example for nucleophilic substitution reaction, and for a free radical substitution, halogenation of a methane is example for the free radical substitution reaction. And in detail, let us understand the free radical substitution reaction. When methane is treated with chlorine in presence of sunlight or a diffused light, there is a replacement of a hydrogen atom by a chlorine atom to form the product, that is chloromethane. And since this reaction, that is the substitution reaction, involve the free radical, this type of substitution reaction is called as free radical substitution reaction. And if the reaction is carried further, all the hydrogen atoms of methyl chloride or successively replaced or substituted by Cl chlorine atom to get the carbon tetrachloride. So this is all about the free radical, which involves a free radical as an intermediate in the substitution reaction. Coming to the next type, that is the electrophilic substitution reaction. When an electrophile such as NO2 plus or X plus or R plus or SO3H plus is involved in a substitution, then that reaction is called as electrophilic substitution reaction. So generally, alkene and aromatic hydrocarbon undergo electrophilic substitution reaction where there is a replacement of the hydrogen atom with an electrophile. So here, taking an example of a nitration of the benzene, the hydrogen atom attached to the ring or nuclear hydrogen will be replaced by the electrophile NO2 to get the nitrobenzene, a classical electrophilic substitution reaction. And there are other examples like nitration, sulfonation, halogenation, or the Friedel-Crafts alkylation and acylation. Coming to the next type of substitution reaction called as nucleophilic substitution reaction. When the substitution reaction involves the attack of a nucleophile, the reaction is called as nucleophilic substitution reaction. For example, when I take an alkyl halide in presence of a nucleophile, the halogen atom is substituted by a nucleophile to give the corresponding product and an alcohol is formed. Generally, the nucleophilic substitution reaction or designated by SN. S stands for substitution and N stands for nucleophilic, that is the reactive intermediate. And once again, the based on the order, that is, if it follows, we call it to be SN1 nucleophilic substitution. If it follows the second order, we designate to be SN2. SN1 nucleophilic substitution reaction generally occurs in a tertiary alkyl halide. It is a two-step mechanism with the involvement of a carbocation. And here, the rate of the reaction depends only on the concentration of the reactant and not on the reagent. And hence, it is a first order reaction. Coming to the SN2 nucleophilic substitution, which is occur mainly in the primary alkyl halide, it is a single step mechanism where the breaking and the formation of the bond takes place simultaneously in the transition state. Here, the rate of the reaction depends both on the concentration of the reactant as well as the reagent, and hence this is a second order designated as SN2 reaction. Coming to the next type of the reaction, which is called as addition reaction. Generally, an unsaturated hydrocarbon which have a double bond or a triple bond is characterized with an addition reaction. So here the reaction in which an atom or a group of atoms are simply added across a double or a triple bond without any elimination is referred as addition reaction. And here one thing, the geometry of the reactant and the product is not the same. So there is a change in the geometry of the in the reactant and the molecule. And in detail, in the addition reaction, generally unsaturation is mainly because of a double or a triple bond. And during this addition reaction, the pi bond is broken and in the resulting in the formation of two sigma bond to satisfy the valency. So here the hybridization also changes from sp2 to sp3, and hence there is a change in the geometry from the reactant to the product. So let us take an example for an addition reaction. For example, ethene and unsaturated, an addition of HBr occurs across the double bond, forming the product, that is bromoethane, and where a pi bond is broken with the formation of two new sigma bonds. Another example is a cyclohexene, where there is an addition of a water molecule to get the cyclohexanol. And generally, as said, unsaturated hydrocarbon, it can be an alkene or alkyne, undergo addition reaction to get the saturated hydrocarbon. Let us take an alkene and the addition reaction. So the alkene, upon addition of an hydrogen in presence of a nickel catalyst, results in the saturated hydrocarbon, that is the ethane, in a single step process. When we take the alkynes a triple bonded, this undergo addition reaction in two steps to form saturated compound. For example, when I take the alkyne, the propine as an example, there is an addition of hydrogen across the triple bond to give the propene, and this further reacts with hydrogen to get the saturated hydrocarbon, that is the propane is formed, and hence it is a two-step process for an alkyne to getting converted to an alkene. And coming to the different types of addition reaction, once again based on the nature of the reactive intermediate, we are going to classify the addition reaction into electrophilic, nucleophilic, and free radical addition reaction. So coming to the electrophilic addition reaction, when there is an addition reaction involving an electrophile, we call that to be electrophilic addition reaction. For example, to an unsaturated, addition of HBr results in the formation of a saturated, that is 2-bromobutane, that is 2-butene. When it is treated with HBr, results in the formation of 2-bromobutane. So this is an example for an electrophilic addition reaction. And the second, we are going to for the nucleophilic addition reaction, which is a very common among the carbonyl compound, where we have a carbon bonded with the double bond with the oxygen. So carbonyl compounds generally undergo nucleophilic addition reaction. So during the addition reaction, there is an addition of a nucleophile across the carbon double bonded oxygen, resulting in the formation of the product. For example, when we take a ketone and upon addition of hydrogen cyanide in the basic medium, that results in the formation of cyanohydrin. So, all carbonyl compound, whether it's an aldehyde or a ketone, reacts with hydrogen cyanide to form the corresponding cyanohydrin products. And the other example for the nucleophilic addition reaction among the aldehydes and ketones, or the addition of an alcohol, resulting in the formation of hemi or acetal or ketone group. Coming to the last one of the addition reaction, the free radical addition reaction. The addition reaction of an unsaturated unsymmetrical alkene, for example, propene, in the presence of peroxide, is governed by the free radical mechanism to give the anti-Morkonix product, and since the reaction involves the free radical, this addition we designate to be the free radical addition reaction. Coming to the next type of the reaction, which we call by the name elimination reaction. So, as the name suggests, the elimination reaction here it is completely reverse of an addition reaction. So, in an elimination reaction, this involves the removal of atom or a group of atom from two adjacent atoms in the reactant molecule. And here it is a reverse of addition reaction. Hence, two sigma bonds are lost to form two 1 pi bond. So, elimination reaction which involves the removal of atoms resulting in unsaturation, and here as already said there is minus of 2 sigma and formation of a new pi bond. Generally the leaving groups among the elimination reaction can be an XOHO or N2 plus so on. And let us take a few examples for the elimination reaction. So the elimination reaction, an example, dehydrohalogenation. So D means removal, hydrogen, halogen. In the dehydrohalogenation, we are removing a hydrogen atom as well as a halogen atom to get an unsaturated product, that is the alkene. For example, an alkyl halide in presence of alcohol at a higher temperature, there is a removal of hydrogen and halogen to get an unsaturated alkene. For example, ethyl bromide or elimination, we get the unsaturated ethene as the product. The next example for the elimination reaction is the dehydration. So D means removal, hydra means water. So when you remove a water molecule across two carbon atoms resulting in unsaturation, we call that process to be dehydration. For example, when we take an alcohol and heat in presence of a sulfuric acid, we are removing a hydrogen and hydroxide group from two successive carbon atoms. As a result, an unsaturated alkene is obtained. For example, when I take an alcohol 1 propanol, heat in presence of sulfuric acid, we get an unsaturated, that is the propene. So these are a few examples for elimination, that is dehydrogenation and dehydration. Coming to the classification, we can classify the elimination reaction depending upon the removal of the atoms either from the same or from the neighboring or from the carbon atom 1 and 3. So when an elimination reaction involves the removal of atom from the same carbon atom, it is called as alpha elimination or 1-1 elimination. For example, chloroform in presence of KOH, there is an elimination of a Cl as well as hydrogen atom to get a reactive intermediate, that is the carbene. So this is an alpha or 1-1 elimination. Next, when we come to your beta elimination, when the elimination takes place across the successive or adjacent carbon atom, this we call it by the name beta elimination. And for example, alkyl halide in presence of KOH, we get the alkene. Here there is a removal of two atoms among the neighboring carbon, and hence it is a beta elimination. Coming to the last, that is the gamma or 1-3 elimination. When elimination takes place across the first and the third carbon atom, resulting in the formation of a cyclic structure, we call it by the name gamma elimination. For example, 1,3-dibromopropane heated in presence of a zinc There is an elimination of two bromine atoms from the first and the third carbon atom to form cyclopropane, an example of gamma elimination. This is all about the elimination reaction, and this is a Digital Learning Department of Collegiate Education, and thanks to